Elijah. How are you? It's nice to see you, or at least this much of you. I miss all of you guys. I do. It's been a long time. I miss you, Luke. It's been even longer for you. So, okay. Did most of you? Okay, who watched the lectures I posted this week for this class? Got 1, 2, 3, 4. Okay, for the rest of you, did you watch the lecture that I posted about the project description? I'm getting a head nod. That's always good. You're in a boot again? You okay?
I broke it over the break.
Oh no, what were you doing? See, that's the manliest way to break it. So, it's awesome. Okay. As you can see, I'm very easily distracted. It's my bad. I have no idea where I was. Right, so this class is a lot different from, for those of you who have had me in a class before, this class is different than how I've taught before. The goal of this class is to complete 2 projects. And the reading assignments, the modeling learning assignments, what they are intended, and even the quizzes, are intended to kind of develop the knowledge that's needed for you to be able to do these projects well. Okay? In Doan's program, we have a very heavy emphasis on hands-on learning. And hands-on learning, it gives you a lot of perspective into how to actually do a project. A lot of people complain in college, specifically as engineers, that they have no idea what engineers do. Engineers don't take tests. You're not going to go to your employer and have your employer throw a test in front of you and say, we have a client who really needs you to fill out these multiple choice questions. Go! Nobody's going to do that, okay? And yes, I give you multiple choice quizzes every week. And yeah, they are challenging. I won't discount that. It's supposed to be hard. But it's supposed to help develop the knowledge and the understanding of what are we really doing in engineering. And what we're really doing is what we're going to be doing in class. I don't want to sit up here and lecture every week. In fact, this is probably the most I'm going to speak on a Thursday in front of you this semester. My goal coming class on Thursday is to help you complete your projects. Because by doing those projects, you will learn the skills and the professionalism that you're going to need to know what a real engineer does. Okay? Or so that you can understand the rest of us peons in this world. But it's going to give you that foundational knowledge, okay? And you're going to take that knowledge that you're learning in the lectures and in the readings, and we're going to apply it here, okay? For this first project, I'm not assuming that you know all of the stuff that we're talking about right now in lectures. Okay, this week we're talking about teams. Teamwork is a huge aspect of project management, of team design. Working in a group with one other person, which is what you're doing for your project, you don't get to utilize a lot of the theory of teamwork. And that's okay. Again, this first project is kind of it's an introduction to project management of sorts. But it's also kind of an understanding of what all the tertiary elements of engineering are. Engineering isn't just pushing pencils. It's not just sitting around and doing calculus. Some people would love that. Engineering is a lot of critical thinking. And you can't learn critical thinking doing multiple choice tests. You can't learn critical thinking listening to some weird guy throw markers into a trash can. Okay? You learn critical thinking by, yeah, I'm glad you're in this class. Everybody else is in the other one. At least I can split up the dissension. It's divide and conquer. Where was it going? Right. Critical thinking is best done by actually doing stuff, making decisions. Okay? And in this environment, if you make a mistake, the worst that you can get is an F. The worst you can get is you have to retake this class. And even then, if you hand in all of your assignments, it's very hard to get an F in this class. I have never had any student get a C or lower in this class and hand in all of their homework. All right, so you hand in all your homework, I pretty much guarantee you a B. Okay? So even then, the worst you can do, making a mistake, is get a B in this class. That is the worst. In real life, you make a mistake, you can kill someone. In real life, if you make a mistake, you can be responsible for millions of dollars worth of wasted product. You get fired from a company. There are real consequences to making mistakes out in industry. However, most mistakes made in industry are compensated for. And engineers are terrified of them because nobody wants to be that guy. But the reality is you're going to make mistakes. And in this class, you're going to make mistakes. You're not going to do the best job. But the only way you can know how to be a better engineer is by sitting down and doing it. Coming back and doing it again. Doing it better. Looking back and saying, what could I have done that would have been better than what I did? Okay? You get to that place, you're already a better engineer. And in fact, if you can sit down and take criticisms, not only of your peers, but also of yourself, you're in a better position than many engineering graduates. Engineers with 1 to 2 years of experience under their belt oftentimes exist terrified of their superiors. Or they exist super confident in their own abilities. I just met with a person this week who was telling me that one of the issues with technicians is technicians go out there and they build stuff and they do all the hands-on work for years. And then these young engineers come in and they're like, oh, well, I know engineering and you only have a high school diploma and I'm an engineer. I took calculus. And they come in and they start telling the technicians what to do. And the technicians are like, that's the stupidest thing I've ever heard. But the engineers think they know everything, and the technicians know they don't. And so if the technicians listen to the engineers, the product sucks, management gets called, and it's terrible. Because really, education, it has its merits, and it teaches you how to do a lot of things, but it's the experience that changes you from being that kid who just like, well, you're going to do everything I said, and it's going to be wonderful. We're all going to poop rainbows. It changes you from that into, all right, let's make this work. Okay? Not to say that you can't poop rainbows. I don't know if any of you are unicorns. I haven't checked, nor will I. This is a unicorn check class. Okay, so that is the goal of what we're doing in person. I don't want to sit here and lecture. I don't want to go through all the lecture material. Those videos are going to be posted online. Okay? And you're expected to just watch them, take notes, take the quizzes, do your best. The real meat of this class comes in being able to do projects. And everything that we talk about is supposed to enable us to be here. So, for those of you who did or did not watch the video I posted on what the project is, here's an overview. You've been given a project to work with one other person to design a park and playground space. The park and the playground space is 600 by 400 feet, I believe. I ended up making it bigger than I wanted to because I wanted to give students the opportunity of, if you wanted to put a sports field in there, you could. It turns out you need a lot of space for a sports field. But you have full capabilities no budget limit to propose what this should look like. Okay? Now, there is not one right answer to this problem. In fact, there's not 10 right answers to this problem. There's an infinite number of correct problem answers. And as we've talked about in this class, measures of quality are ultimately what makes and decides what is best. If a city going and investing in this property, if they decide that cost is most important, they're going to go with the cheapest option no matter what. Doesn't matter how awesome it is. If they decide that community involvement is most important in trying to build a community, they're going to spend more money. Not every city puts that cap on, we have to go with the cheapest option all the time. Sometimes the cities care a lot more about, well, what can it do to build the community? What is the cost value to this? Is this going to be a meeting place for all of the local kids? Is this going to be some place where clubs can meet and join and you know, LARP? Is this going to be something that people want to use? Or is this going to be just a giant green space that we're going to spend hundreds of thousands of dollars on, and that's it? What's going to be the most cost-effective option? Okay, what's going to be the best value to the community per dollar? And that's your job as an engineer to figure it out. Now, I doubt any of you have any experience with proposing things to city governments. That's usually not the kind of experience people come in with in this class. But that is your goal. When cities decide they're going to be doing projects like this, they will solicit bids from local agencies. You'll have a civil engineering firm out of Seward come out. You'll have a civil engineering firm out of Omaha come out. You'll have a civil engineering firm out of Lincoln come out. And they will propose a site plan. And they'll say, here's how much it's going to cost. Here's how long it's going to take to build. Here's what it's going to look like. Here's all the equipment. Here's how much it's going to cost to maintain. Here's where all the lights are, fences, sidewalks. Here's how traffic's going to flow. They put together the whole proposal, and then they go to the city council board. They stand in front of them and they say, here's what we're doing. City council board looks at their proposal, looks at the proposal from Seward, Lincoln, Omaha company, and they go, well, we like this one. And then they choose one, and then that company then turns around, takes their proposal, and spits it out into really fine, detailed drawings, which they then hand off to contractors, and those contractors build. They order all the parts, they order all the materials, they hire the workers, they get the workers put in place, they direct them with the plans, they make sure the project is built satisfactorily, and then they get paid, project done. Your part in this is we're not actually going to build this, but your part is we're putting together a proposal that you would take to a city council to explain, here's how I think this would look. Okay? Now, this wouldn't be the kind of level of detail that a full set of plans would be. This isn't something you're handing off to a contractor. Most of you guys in here are freshmen. I wouldn't expect that you have the kind of knowledge or experience to be able to hand contractor level plans off to somebody else. If you can, prove me wrong. Put that out there. Prove me wrong, feel free. I'd love to be proven wrong there. Students have surprised me time and time again. But there is a lot of information that needs to go into a proposal. And by the way, you don't get paid for putting together proposals. Company puts together a proposal, and then you compete with two other companies. Your proposal gets shot down. You then invested all of those hours for absolutely nothing. Welcome to the world of bidding and engineering and why engineers get paid so well. Because you have to work a friggin' ton of time in hopes that you will make money. It's an investment job. So nothing is guaranteed. Okay, so what I would like for you to do right now is go ahead and get in partners. I'm gonna end the live stream because that's everything I have to say. Other than, wait, hold on. There's gonna be a lot of AutoCAD involved in this project. For those of you who do not have AutoCAD access, it would probably be best if you partner with somebody who does have AutoCAD. We do have some departmental computers that we can use in this class, during this class. I will make them available to you during this class. So if you need AutoCAD, you don't have it, absolutely, you can do it. If you have a Mac, you can download AutoCAD for Mac. I'm not going to be teaching AutoCAD for Mac because it is a slightly different program than AutoCAD for Windows. The functionality is identical, so it's not an issue. I would not advise you buy another computer for this class. But work with somebody who has AutoCAD, and you're gonna need, both of you are gonna need to have to spend a lot of time working in AutoCAD. I am not going to be taking this class lecture time to talk about AutoCAD. I'm not gonna stop everyone and say, here's how to draw a line. Today we're drawing a box. I'm gonna draw a cat. We're not doing that in this class, okay? We will do that in the lectures that I'm going to be posting on Monday. I posted it on Tuesday this week because I was a little scatterbrained and I completely forgot that I was supposed to do it on Monday. I don't like posting it on the day when the Tuesday class meets. I like to at least give some time. So I will be posting those on Monday at 1 o'clock. I'll start. We'll have up to an hour and a half of lecture on Mondays. All right. That will include material that's going to be on the quiz, and it's going to include a lot of AutoCAD stuff. All right. This coming lecture, we're going to be talking about blocks. We're going to be talking about layers, some of the things that are not in the modeling learning assignments. Modeling learning assignments are kind of an introduction to AutoCAD. I'm going to be teaching you how to take that introduction to AutoCAD and turn it into useful stuff. That's my goals. All right, any questions about that? If you want to spend your own time learning more AutoCAD, I will not stop you. It's a useful skill. As we discussed in one of our lectures, modeling is important in engineering because it is a very, very effective form of communication. In this project, it is the form of communication because if you hand me something, if you just walk up to me like, hey, I got this park idea, it's pretty awesome, it's got unicorns on it, costs $5. I'm going to tell you to prove it. And the way you prove it is with drawings. It is a proof because drawings in today's world are accepted as if they were real physical solutions. That does cause some problems sometimes, but in the world of civil engineering, you're not going to go out there and build a park and be like, here we go. This is your park. Are you going to pay me for it now? It doesn't work like that. It takes a lot more planning. So it is critical that you understand how to do modeling, and that's why modeling is such an important piece of this class, why we do so much with AutoCAD. And later on this semester, we'll do a lot more with SolidWorks. Those are the two programs we use extensively in this program. Some people will use Revit. Also, I never learned Revit. I learned AutoCAD architecture, which is different than Revit, but I don't teach Revit because I used to try to, but it was like jamming 3 programs into a class where it's hard enough to jam 2 programs. All right, I'm gonna end the live stream. You guys meet in partners. We're gonna go over the project again and what I'm expecting of you. For those of you who are on